Okay, so this chemical reactions, okay, rate of reaction, this is a important word. Okay, this whole chapter is on rate of reaction. So it measures the speed at which the chemical reaction will take place. Rate means the speed. Okay, so it can, how to know how fast the reaction happen? There's two ways to measure. Okay, first way is to check the amount of reactant used up over time. Okay, meaning when you put the two reactants together, then you start your stopwatch, then you check how much of the reactant is gone, how much did the mass decrease over time. Then you can plot your graph to see how fast it decreased. Okay, so that is one method. So if you look at your graph, when they plot it, you will notice that the graph is going downwards because the mass is decreasing. Okay, but at the end, it will be a horizontal line because when all the mass is already like everything is reacted already, there will still be some mass left over and it will be stagnant. So that's why it's a horizontal line. Okay, then the how to know which one is faster. So the one with the steeper gradient means it's a faster reaction because you notice it become like down, okay, like it reduce the mass much faster than the other one when the gradient is a bit lesser. Okay, but eventually it will still reduce unto the same thing. Okay, because they are the same amount that reacted together. So end up it will be the same. Okay. Another way to measure how fast is the speed is to measure the amount of reactant products that is produced over time. Okay, every time when you explain, make sure you must say over time. Don't just say measure the amount of reactant product. Okay, because if you don't like compare with time, then you don't know how fast. Because speed is about the volume divided by time. Okay, so how much of the gas example is being produced? So example like this one, you have your marble chips. Marble chips is calcium carbonate. Okay, so calcium carbonate with acid, you will get salt plus carbon dioxide plus water. So you measure how much carbon dioxide is produced over time. Okay, and you notice your graph is going to be a increasing graph. And the one with the steeper gradient means it's a faster reaction because there's more, like the gas comes out much faster than the other one. Okay, but at the end, they will also follow, both will eventually be at the same line because the amount of the HCl and the carbonate that you put together is the same. So the amount of gas that come out will be the same. So it will eventually be the same. Okay, unless you have two different experiments, the other one, maybe your mass of maybe the carbonate you put lesser. So of course, then your volume of gas that come out will be lesser. Okay, then it will not follow the same horizontal line. Okay? Okay, so but you just make sure this must be an increasing graph because it's the amount of product that is being produced. Okay, so this page here is just showing you how to know which one is steeper. If you can't tell, then you have to draw your tangent. Okay, but the one that has the steeper slope will be the steeper one. The slope is like higher. Okay? Okay, then we go down to this part here. So collision theory, okay, what does this mean? So this explains the change in the rate of reaction. Okay, like how come the rate of reaction will change is because of this, the way that the particles collide with each other. So this theory states that the more frequently the particles collide, the faster the reaction will take place. Okay, so you got reactants, the more that they collide, the faster the reaction takes place. Another one, the particles must collide with a minimum energy known as the activation energy in order for the product molecule to be formed. Okay, meaning if just collide, there is no use if the energy is not there. Okay, they must collide with at least the minimum energy called activation energy, then the product will be formed. Okay, and this type of collision is called effective collision. Okay, so the factors that will affect all these collision we have over here. Okay, so all these factors will affect how steep the gradient is, how fast something will happen. Okay, so the first one, if you have a aqueous reactant, so the higher the concentration, the higher the rate of reaction. Okay, why? You need to explain. Because if you got higher concentration, means that there is more particles per unit volume. Okay, because if you remember, concentration is mole per dm cube. So if you got higher concentration, means there is more moles per dm cube, more particle per dm cube. Okay, if you got more particle in that unit volume, means there's going to be more frequent collision. They will collide more, and there's a higher chance that you will get effective collision rate, higher effective collision rate. Okay, so therefore you have a higher rate of reaction. Okay, when they ask you to explain why concentration will lead to higher rate of reaction, you must put in all these keywords. Okay, everything must be there. So it cannot like one is missing or what. Okay, if not, 1 mark will be gone. And the most important one is this effective collision rate. Okay, so if let's say we talk about pressure, pressure only applies if your reactant there's any gases involved. Okay, so if you got higher pressure, but if it's just liquid, it doesn't affect. Okay, so higher pressure will lead to a higher rate of reaction. Why? So we need to explain. If you got higher pressure, means the particles are closer together. Okay, means there's going to be more frequent collision and higher effective collision rate. So therefore, higher rate of reaction. Okay, same thing. It's a storyline. Okay, so how to increase pressure? We can do that by either making the vessel smaller. You make it smaller, then the particles will like collide more. Okay, or in that volume, you just put in more particles. Okay, so then the pressure will be more. Okay, so this is another factor. The third factor is the particle size of the solid reactant. So this will only affect if you have a reactant that is in the solid form. Okay, so the smaller the solid, the higher the rate of reaction. Okay, why? Because if something is smaller, means that there is a larger total surface area that is being exposed for the reaction. Okay, because if you got something big, let's say this is something big, when reaction is happening, it's only 6 surface that it will react on. But if this big one can be split into smaller ones, then at one time the particle can like hit at more surface, so reaction will be faster. So if it's larger total surface area, means more frequent collision, again means got higher effective collision rate and therefore higher rate of reaction. Okay, another one is temperature. Temperature will affect all solid, liquid, gas. Okay, if you got higher temperature, it will affect two things. You must make sure your pointer 1 and pointer 2 must be there. Okay, if it's higher temperature, so the particles will gain energy. Okay, when they gain energy, they vibrate and move faster. So end up you have more frequent collision, higher effective collision rate. Okay, another thing is because if you got higher temperature, means now more of the particles will have the energy equal or greater than the activation energy. Okay, there's more of them that is able to reach the energy. So therefore, there's a higher effective collision rate, higher rate of reaction. Okay, so far can follow? Okay, the last one is your catalyst. Okay, if they put a catalyst inside, catalyst is something that speeds up a reaction. Okay, so if you have higher catalyst, what the catalyst do, it will allow the reaction to go by a different route with a lower activation energy needed. So maybe originally the reaction need like 10 joules to react. Okay, but now with the catalyst there, you only need like 5 joules, it can react already. So therefore, end up more particles will be able to have that 5 joule, the lower energy, equal or greater than the activation energy. So then, again, higher frequency of effective collision, higher rate of reaction. Okay, so all these factors will affect the gradient, how steep the gradient is. Okay, so far okay? Okay, so like over here, it says that catalyst will speed up the reaction. Make sure that you know that catalyst, even though speeds up, but it will not be involved in the reaction. Okay, so it will still end up be there, be at the end. It will not be used up in the process. Okay, and most of the transition metals will make good catalysts. Those in the periodic table, in the middle of group 2 and group 3, that is the transition metals. So they make good catalysts. So example, like you have your Haber process, where you make ammonia, okay, iron is there as a catalyst. Iron is not during the production, it's not involved in the equation, but it will just be there to speed up the whole process. Okay, then if you have like this hydrogen peroxide, decomposition of hydrogen peroxide, you will need manganese oxide as a catalyst. Okay, and in our body, biological catalyst is enzymes. Okay, so this one is more for bio part. Okay, so just read through. Okay, we look at the graph part at the bottom.